Suppose you get your secondary data from an internet search. You Google something and you come across some information. How do you evaluate that secondary data? Well, the first thing you should ask yourself is, what does the URL tell you? So if you have a choice of information from, say, Google or Statistics Canada, if the information is collected by Statistics Canada, because we're looking at information related to unemployment or inflation, it's better to use the source rather than an organization that is pulling data from the source, because that information may be taken incorrectly, interpreted incorrectly, or might be old. So it's always better to pull it from the source. So if you're looking for data about the economy, for example, you want to pull the information from the government that is the one who is managing that economy. So we would look for websites like .gov to indicate that it is a government source, or we could look for, in Canada, we're looking for .ca to tell us that it's Canadian information, and then we have .gc to show that it's the government. We could also look at whether or not it's an academic source. So typically ones that are ending in .edu tell us that it's educational source, and we would tend to trust that over a more for-profit institution. If it is a non-profit, it often ends in .org. A for-profit often ends in .com. Now, that's changed a bit because you can now choose your own extensions for that, but for the most part, the government and academic ones have been a bit protected. So you want to look at, what does that URL tell you in terms of the original source of this information, who wrote this information. If it is coming from, say, a newspaper or journalism source as opposed to an individual blog, it's more likely to be vetted, peer-reviewed. If it's academic, it's more likely to be peer-reviewed. So we're looking for, can we trust this information based on the reputation of the organization that is posting it? How old is the information? When was the information last updated? You can often scroll to the bottom of web pages to see the date as to when that page was last changed. How old is the information that you're looking at? If it's old, is it no longer relevant? Okay. We can also look for other indicators of quality information. Do they reference their sources? Is it a recognized publisher? Are there links to other sites? So we can often measure reputability in terms of how many other websites reference it, whether they trust it. It used to be that you could actually go to a website called alexa.com and it would tell you how many different websites linked, like you could just type in reddearpolytechnic.ca and it would tell you how many other websites linked to reddearpolytechnic.ca, and it would tell you how many websites reddearpolytechnic.ca linked on it. So you could see how connected it was and how reputable it was based on how many times it was referenced by others and whether it referenced others. Now, that doesn't exist anymore, at least in terms of freely available data. Now, if you want information about how many web sources link to your page, you can pay to get that information about your particular website, but you can no longer publicly get the information about anybody else's website. So unfortunately, and that's why I've kind of struck it out there, is that avenue that used to be available no longer exists to see that. But we often determine the quality of a source depending on how many references it makes and how many people reference it. The other thing you want to look at is why the website, why the information was created. So are they trying to sell you something? Are they trying to push a political opinion? Is there a bias here? We need to be a bit skeptical in terms of all information. Is it legit? And so you should ask yourself, who is pushing this perspective, this point of view, this information, and why? And do they have an agenda? So are they making arguments that simply support their political agenda or their bias or their perspective, or is it actual data that we can trust? So when we look at information, we should always be skeptical as to whether or not it is accurate or trustful. So we can look, for example, this article gives us some helpful advice to spot bogus research. And so here in this article, it talks about a study that found cigarette smoking helps marathon runners run faster, right? Does that make sense? That cigarette smoking helps marathon runners run faster? Well, it turns out that increased lung capacity rate is what helps people run faster. And by cherry picking the data, so numerous studies show that smoking boosts lung volume, and larger lung volume was related to higher performance in marathon running. So cherry picking the data and focusing on lung volume between different studies, that doesn't mean that cigarette smoking helps marathon runners run faster. Okay, so we got to be careful about cherry picking data, pulling information that supports and not other information that is opposed to it. The other article here says eating meat increases the risk of death, and that it has a much greater impact on the risk of death than car accidents and guns. So the key here is that we can measure correlation, that is when things move together, but it doesn't necessarily mean causation, that one is causing the other. So it's not necessarily the case that eating meat causes death, but it can be that people who are more likely to eat meat are more likely to engage in other activities that are risky, or they might be an older group. So certain behaviors might be tied that actually are the ones that are impacting death. So when we take into account factors such as age, education, weight, exercise habits, we talk about controlling other variables to make sure that we are really measuring the impact of one on the other. We're doing that causal research design. We want to control everything else. So we want to make sure that the two groups, the one that eats meat and the one that doesn't, are people that are the same age, the same body mass index, the same education, the same exercise habits. We can control for those other pieces so that we really are just seeing the impact of the meat eating and not other confounding variables that might be causing that relationship to appear. So we need to distinguish between things that move together and when one causes something else. So we'll get into correlation later, as well as our experimental designs. Another one we have here, this article talks about how caffeine causes breast cancer. And so you got to be careful about fishing expeditions. This one found caffeine intake was linked to increased risk of estrogen, progesterone tumors. And so finding patterns and whether these patterns are statistically significant, we do want to make sure that we're doing rigorous statistical analysis and following appropriate processes in model design and in our analysis. We'll talk about statistically significant to make sure what we see as a difference truly is a difference, or an impact when there truly is an impact. And so we want to make sure that proper statistical procedures are followed rather than looking for and then suddenly finding exactly what we looked for in our research. So we want to be careful and skeptical about data when you are finding either results of analysis of data or the data itself that's been collected by others.